Hello to all. I am Priyanka, Assistant Professor of Mathematics in GJ College of Arts and Science. Today we discuss about the topic is basic of tree and spanning tree. This topic is belong to the subject graph theory and this is for third BSc Mathematics. First, we have to know the basic of a graph. A graph contains a number of vertices and a number of edges. First, we have to think what is vertex. A vertex is just a point. A point is represented as a vertex. Then edges. An edge is a connection between two pairs of vertex is called edge. Then we start the introduction of tree. A tree is a simple graph such that it has a every pair between every pair of vertices. It has a every path between every pairs of vertices and it is a undirected graph and it is equivalent to a connected uncyclic graph and it has a unique path between every pairs of vertices. For example, in the diagram we take a two vertex v and w. The pair v and w has a separate path between the tree and this path is known as this path is a connection between the vertex v and w. This is the example for tree. Then we start the definition of rooted tree. So rooted tree means it is one of the vertex. It is designated to make the root move forward along the designed a designed vertex. This is called rooted tree. It has a edge of a root can be assigned to a natural oriented or either away from or towards the root, in which case the structure becomes a directed root. It is a direction to make a tree in a uncyclic direction. Then how to find out the levels of a vertex in a tree and a height of a tree. So what is mean by level? It is a step of the trees. One step of the trees. Level means it is a simplest path between a rooted tree, that means root vertex, to a specific vertex is called length. Then how to find out the height? The height is the maximum level of a specific vertex to a root is called height. Then we find a formula. We denote h means a height and the level of a vertex is denoted as L of V. Then we make a formula h equal to maximum of L of V. So it denotes the maximum of the level of vertex is denoted as the height. For example, in that graph, it has three levels. So the length of the tree has three levels: level 1, level 2, level 3. So what is the maximum value? The maximum value is 3. So the height of the rooted tree is 3. So hence there only the tree on the right has a height 3 is denoted. Then we see what is internal vertex and what is external vertex. Internal vertex means it has a only one child. Only one child means a vertex has a degree of 2 is denoted as internal vertices. So internal vertex it has a only 2 degrees. That means degree means number of edges incident on a specific vertex is denoted as a degree. Likewise, uh, the internal vertex means it has a degree 2 and it has a only one child. Then external vertex. External vertex means it has no child. That means it has a degree only 1. The degree of the vertex is 1. It is called term terminal vertex or external vertex. From the diagram, we have to count how many internal vertex and how many external vertex. In the diagram, there are 4 vertex has a degree 2 and a 4 vertex has a degree 1. So hence in the diagram there are 4 internal vertex and also same 4 external vertex or terminal vertex. Then we start subtree. So what is a subgraph? So a number of vertex is contained same on the major graph is called a subgraph. Likewise, a subtree is a tree that contain the vertex are in both subtree and a main tree is called subtree. For example, in the diagram, we take a dark portion as T dash graph and the whole graph is taken as a graph named as capital T. So we have uh, to find out the vertex and edges. The vertex in the T dash is also contained in the vertex of T. Likewise, the edges in the graph T dash is also contained in the graph T. So, this is the example for subtree. Then we have to find out the properties of tree. So, from the above diagram, we take the graph is assigned to be named as capital T. We denote capital T is a tree, then T is a connected and also a acyclic graph. Yeah, acyclic graph. A acyclic graph means there is a no circuit make on the graph. A graph has a no circuit is denoted as a acyclic graph. That means a acyclic graph has a no cycle. Likewise, a tree is a connected and also a acyclic graph. A acyclic graph contains n minus 1 edges. This is one of the property. Then property 2, any node of a tree make a root of the tree. So edge every vertex of a tree make a another tree or it is a root of the tree. Then each node except the root node has a parent node. That means every vertex in a tree has a parent tree or a parent vertex. That means in a tree a rooted vertex other than other vertex has a again parent tree. That means again parent node. Then last point, every edge or every branch of a tree is connected to a another vertex. That means it is a parent or it is a branch of that tree. These are the properties of tree. Then we saw what is spanning tree. A spanning tree is nothing but it is also the one of the subgraph of subgraph. So the subgraph is denoted as a spanning tree with some condition. The subgraph is contain all the vertex in the basic graph G is called spanning tree. In the diagram, we make a spanning tree. So the spanning in the basic graph G is taken sum of the vertex A, B, C, D, E, that's all. In the same graph we make a spanning tree. That means all the number of vertex in the graph G is also connected in the spanning tree. So we make the another graph and it is named as capital T. Then we analyze the both two graphs. T is a subgraph of G. That is the first point. So it is the subgraph of the main graph G, and it also contains all the vertices in G is also in the graph T. So this is known as spanning tree. Then, how to find out the minimal spanning tree? It is based on to put on the weight of the graph is to be calculated. First, we have to weight the graph. That means we have to put on the values for each edges in a graph, and to make the minimal weight along the two pairs of vertices. This is known as minimal spanning tree. How to find out the minimal spanning tree? That means minimal spanning tree value. It is based on two algorithm, that means two basic problems. This is known as Prim's algorithm and Kirchhoff's algorithm. So now algo we see the steps to find out the spanning tree in Prim's algorithm. First, we make a graph G. Then, how to find out the minimal spanning tree? First, we have to select a vertex and named it as A, and to make a set of graph T equal to A. Then again, we have to select the smallest weight incident on the selected vertex. We have to join the smallest weight to a vertex A. Then we have to named as B. So hence we have a set T equal to AB. Again repeatedly we have to add a smallest weight instant on either A or B. So add upon the vertex along with A and B and call it on up as a letter C. We have a graph T equal to A, B, C. Then we have to repeat the steps until to cover all the vertex in a graph. Then we have to find out at last the minimal spanning tree. That means the spanning tree has a minimum weight. Then it is called as minimal spanning tree. So in the diagram there are lots of vertices in the diagram. How many vertices? There are seven vertex. So how to find out the minimal spanning tree along with the weights? We have to put on the values 2, 1, 3. So likewise we make the from the values we make the smallest path between the every pair of vertex. So then this is the algorithm of prims. Then the second method is Kirchhoff's algorithm. Then the second method is Kirchhoff's algorithm. This is the one of the method to find out the minimum spanning tree along with to make a color on a vertex or edge. First we find out the edge in a graph with a smallest weight to make it as color. Then we again make a smallest then again we have to find out the smallest weight on the graph and the color make the another color to that edge, and we have a one condition: the vertex or the edge does not make any cycle. So a spanning tree has no cycle, so this is the condition. So again repeat the steps step 2 until to cover all the vertex in a graph. Then at last the result we have to find out the minimal spanning tree. So first method is we have to weight the graph, then we have to join the vertex along with their weight. Then the second method, Kirchhoff's algorithm, we have to put on the colors on a smallest weight of vertex. These are the two methods to find out the minimal spanning tree. So these this all enough to know what is tree and what is spanning tree, and also how to find out the minimal spanning tree. Then that's all. Thank you.